By independent and dependent probability, that's really for compound probability. What happens is you have a probability for one instant, one event, and then you have a probability for another event. So you're going to have to multiply it. So independent events mean the outcome of one event does not affect the outcome of another. So the term with replacement indicates an independent event. That means we're going to do some examples of this. So example, you choose an apple from 2 green apples and 3 red apples. You replace it. You put it back into the bag like nothing happened. And then you choose another apple from it. So you choose a green, then you choose a red. So it's like 2 different events. Then you have to multiply it to find the probability of both events. Dependent events is the outcome of one event does affect the outcome of another. The term without replacement indicates a dependent. For example, you have 5 apples in a bag. You pick an apple. You take the apple and say, ooh, I'm hungry. Ooh, Snow White is around. Let's kill or poison Snow White. So you took the red apple out. Now you only have 4 apples left. So what's the probability of getting another apple? So it'd be 2 out of 4. So there is an effect on it because you took an apple out. You ate the apple. It's no longer there. So the bag contains less apples. Then you find the probability of the first event, the second event, then you multiply the 2 events. So example, we have 10 buttons right here. You draw a button with replacement. So you draw a white button twice. So I draw a white button first. How many white buttons? There's 3 out of 10. Then I put it back into the bag. How many buttons are in the bag still? 10 of them. Then I draw another white. There's 3 whites out of 10. I multiply these 2 events and I get 900. So there is a 9% chance or 900th chance of me getting 2 white buttons in a row. Next one. Oh goodness, why is it not moving? Alright, so let's try without replacement. I draw a white button. How many white buttons are? There's a 3 out of 10 chance of me getting a white button. But I do not replace it. How many buttons are left in the bag? Only 9 buttons to choose from. Then I choose a white button again. There's 2 out of 9 chance now. Because remember, I took a white button. I did not replace it. So what is the probability of getting a white button the first time around? 3 out of 10. A white button the second time around? 2 out of 9. It is 6 out of 90, which simplifies to, if I divide by 6, it'd be 15, I believe. 1 out of 15 chance of this happening. So it's going to be very rare of this happening, getting 2 white buttons in a row, if I do not replace it. Next one. Let's erase it. Let's restart this question again. I draw a gray button, then I draw a white button. So what are the chances of me drawing a gray button? Half of a chance. 5 out of 10, or 1/2. Times. Then I draw a white button. 3 out of 10 chance. If I multiply this, I have a 1,500 chance, or 15% chance of drawing a gray than a white, which simplified to 320. Without replacement, I got a gray button, 5 out of 10 chance. I took it without replacing this gray button. How many buttons are left in the bag? Only 9 buttons. Then I've got a white button. There's a 3 out of 9 chance of me getting it. If I multiply this, I get a 15 out of 90 chance, which simplifies to 15, 30, 45, 60, 75, 90, 1 out of 6 chance. Do you notice how with replacement and without replacement, the answers are different? So it matters through the words. Next one. There are 10 buttons in my bag. I draw a black button. It's a 2 out of 10 chance of me getting that. Then I draw a gray button because I replaced it. I put it back in the bag. Then I draw a gray button, a 5 out of 10 chance. It is 10, 100, or 1/10. That's a 10% chance of that ever happening. But what happens if I draw a black button? 2 out of 10. But I do not replace this black button. It's gone. How many buttons are left in the bag? 9 buttons. Then I draw a gray button. 5 out of 9 chances. There's 5 gray out of 9. If I multiply, I get 10 90th or 1 9. Again, notice how they are not the same answer. So, what you're going to be doing, we're going to practice this today. What you're going to be doing is you're going to be drawing 10 rainbow cubes from a bag. Rainbow cubes are these. So you're going to draw 10 rainbow cubes from the bag. You write down the colors. For example, let's just say, let's pretend I have yellow, 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 purple, 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 red, red, and a green. 1, 2, 3, 6, 9, 10. Perfect. Find the probability of drawing a yellow. 3 out of 10 chance. Find the probability of selecting an orange. 0 out of 10 chance. Actually, I need orange as one of the colors. So let me replace this with orange. So it's 1 out of 10 chance of it happening. Next one. Find the probability of selecting a gray. Are there any gray pieces here? No, there are not. 0 out of 10 or 0% of that ever happening. Find the probability of selecting not a purple. I do not want purple. So if I do not select purple, there is a 1, 2, 3, 4, 5, 6 out of 10 chance of that happening. Or 3/5. Now, let's make it harder. Find the probability of selecting a yellow. So let's go back. Yellow. How many yellows do you see? 3 out of 10. Replacing it. That means I took this yellow, I put it back in the bag. So how many cubes do I still have in the bag? 10 of them. Nothing's changed. Now I select an orange. How many orange do you see? 1 out of 10. So the probability of this happening is 3 out of 100 or 3% chance of this happening, of getting a yellow, then getting orange right away. That's a 3% chance. Odds are very low. What happens if I find a probability of selecting a purple? How many purples are there? There are 4 out of 10. Replacing it. I mean, I put that purple I took out, I put it back in the bag. Like nothing happened. So it's still 10 in the bag. Now I choose yellow. 3 out of 10. So that is a 12/100 or 12% chance of this happening. If you want to simplify, it'd be 6/50 or 3/25. So that's a 12% chance of happening. Find the probability of selecting a red, keeping it, then the probability of selecting a yellow. That is getting even harder now. Keeping it. Or that is without replacement. So let's go back. Red. Where is it? There's 1 red out of 10. But I have to keep it. So by keeping it, there's no mas, no more. How many cubes are in the bag now? Only 9 cubes. So what do I need to select now? I need to select a yellow. So out of the 9, there's 3 yellows out of 9. So what is the probability of this happening? 3/90th or 1 out of 30 chance. I mean, that's really, the odds are really low that's going to happen. Find the probability of selecting an orange. All right, let's return back to this red. Orange. How many orange do you see here? 1 out of 10. But I have to keep it. So let's keep this orange. No mas. No more. What is the probability of getting a yellow now? How many yellows do you see here? I see 3 out of 9 yellow. Hey, that's the exact same answer as my previous 1 out of 30 chance. And let's do our last question about this. Find the probability of selecting a purple, keeping it. So how many purples do you see? Oh, let's return back to orange. There are 10 in the bag. How many purples do you see? I see 4 purple out of 10. Remember, I am keeping that purple I took out. Now I want to find a probability of getting a yellow. So I keep this purple. No mas, no more. I only have 9 cubes in the bag. So now I want yellow. What's the probability of getting yellow? 3 out of 9. So it's 12 out of 90 or 6 out of 45. You actually can simplify that by dividing by 3. I should have divided by 6 in the beginning. Oh well. 2 and 15. So it's 2 out of 15 chance. So what we talked about today is independent and dependent, replacement or without replacement. So it does matter if it says with replacement. That means you're leaving it. That means you have two separate events. Nothing happens. So you find the probability of the first event, probability of the second event, then you multiply the two numbers to find the probability or odds of something happening. However, if it's without replacement, it's dependent on what happened on the first one. Then you find a probability of the first event, like nothing happened. And then the second one, you have to take out one of the item from it. So there'll be one less. That's why you look at it as one less. Then you find the probability of the second event with one less, the total. And then you multiply it. So it's independent and dependent probability compound.